And before entering to the set theory, we have studied what is natural number and then rational number, integers, irrational number, right? Then we have moved to what is set. Then there are some operations on set, and then we have moved to relation, and then at the end we have studied function. Correct? This is what we have studied in week 1. So we are more or less going in that direction. So first question is basically I have given some list of real numbers. So these are all real numbers, right? Real number is basically collection of all natural number, integers, rational number, irrational number all together. Right? This is called real numbers. Now among these real number, which one of these are rational numbers and which are irrational numbers? That is what you have to find in this question. So the question is how many rational numbers are there in the given list? Okay. So first one is 2 power 1 by 3. Second one is multiplication of two irrational numbers, that is root 8 plus root 2 and root 8 minus root 2. The third one is 4.879523. And then the fourth one is root 2 by root 3. The fifth one is root 8 minus 2 by root 2 minus 1. And the last one is minus root 48 by root 27. So how many rational numbers are there? You have to give me a number. That how many rational numbers are there? Is it 1?
Sorry,
Is it 3?
can you share the code?
You don't have to enter in this PR tag. You
Okay,
just
okay.
write this in chat, okay? Because that will take time. So I don't want to
Okay.
spend time. Yeah. So I will see the chat. So it will be better if you write down this question somewhere on paper and then solve it, so that I can move to chat and see your answer. Okay. So I am giving you 3 minutes for this because there are total 6 numbers, I think. So it takes 3 minutes and then we will discuss the solution. In the meantime, can one of you, at least one of you, can tell me what is rational number?
Any number in the
These are
form
in
of
the
P
form
by
of
Q.
P upon
It is
Q.
in the form of P
Q
by
not
Q,
equals
just
to 0.
given as P by
Fine. Fine. You can mute yourself now. So any number of the form P by Q, and Q is non-zero. That is important, right? Q cannot be
Yes.
zero.
Yes.
Yeah.
Division by zero doesn't make sense. Okay, fine. So among these numbers, which we can write as P and Q, P by Q, and remember this P and Q should be integer, right? They should be integer now. Integer.
Yes, sir.
So yeah, that is the definition of rational number. Great. Do it.
So there are 2 rational numbers, sir.
Don't give your answer. Write in chat. I will go there and see. Okay.
We need to join PD that website.
No, you don't have to join PR Tech. You just see this question from the slide. So I am using just slides only, and you write your answer on chat. I will see the chat also. So let me see how many of you have written already. Okay. So 2, 3. I have seen 2, 3 more or less. Okay. Someone has said 1. Aditya Verma said it's 4. Okay. Okay. Some of you are saying it's 4. Many of you are saying it's 3. Okay, fine. So can we start discussing, or some of you still want to try?
Start.
So I think, yeah.
Can you please
So I
show the
don't think
question?
it's. Yeah. I will show the question. This is the question. Can you mute yourself? Noise is coming from your end. Yeah. If you are not talking, you just mute yourself. It will help others to listen. Okay. So this is the question. Let's start discussing. Right. So first one is 2 power 1 by 3. Is it a rational number? Cube root of 3. Cube root of 2.
Irrational.
It's irrational number, right? Yeah.
It's irrational number.
Yeah. So basically, this is what we have discussed. So this is the definition of rational number. Now, if 2 is a prime and we cannot, so there is no integer. If we do integer or rational number, if we do the cube root of 2, so it is similar like root 2 power 1 by 2. So it is also an irrational number. So first one is not. What about the second one? Yeah. So this was the second one,
Rational.
multiple of, yeah. So it is basically product of two irrational number. Now we can do the multiplication and we get 6, right? If we do the
It's
multiplication.
simply formula based.
Yeah, right. It is a plus b into a minus b, so it's a square minus b square formula, and you can do the multiplication also if you want. So it is basically 8 minus 2, that is 6. Okay. Anyone has any doubt in this second number? This one?
No, sir.
No, sir.
Okay. So this is a rational number, right? We can express it as 6. So it is 6 by 1. So it is rational number. It is integer, so obviously it is a rational number. What about the third one? This was the third one. So this is a decimal, right? So any decimal number,
Rational.
finite decimal number can be rationalized. Right?
Yes.
This is how we did in
Yes.
our primary school. So it is obviously rational number. So I don't think anyone has any doubt in this one. What about the fourth one? Root 2 by
Irrational.
root 3. It's irrational.
Irrational.
Though it looks, yeah, though it look like p by q form, but as I mentioned, p and q should be integer. Here it is not. Right? Both root 2 and root 3 are irrational numbers, so it's not integer. So it's not a rational number. Anyone has any doubt in the fourth option? This one?
No.
No,
Yes.
sir.
No.
One doubt.
Yeah, go ahead.
Sir, if we evaluate the expression, it comes to some value and it would be in points, just like the second example. And then we can express it again.
Yes, root 3, root 2, if you express root 2 as decimal number, it will never end. It will be an infinite decimal number.
Okay, understood.
After the point, there will be infinitely many numbers. That's why it is irrational. Okay. So it will not be end. So you can approximate it, but it is the approximate value. It is not the exact value. So in high school, we knew that root 2 is basically 1.414. But that is not end. At the 4, it is not ending there. So it is an approximate value of that. Okay. So it is not a rational number. Clear to everyone?
Sir, can I ask question from practice assignment?
Yes, sir.
No, not today. Okay.
Not created.
Today we will only discuss these problems and try to solve this, because you need to solve problem by yourself also, right? So let's focus on problem solving approach for today.
Okay, sir. Okay.
Yeah. So this is what till this step, anyone has any doubt?
No, sir.
No, sir.
No, sir.
No, sir.
Okay,
No,
great.
no, sir.
This is the fifth one, right? Root 8 minus 2 by root 2 minus
Yes.
1.
Yeah.
Again, we can rationalize it and it will give us 2, right? Because root 8 I can express at root 4 into 2, that is 2. I can take 2 common, so I can get 2 into root 2 minus 1. Now root 2 minus 1 get cancelled from denominator and numerator, so I will left with 2. So this is an integer, so this is 2 by 1, so that is rational number. Okay, so this one is also a rational number. And for the last one, again we can do the simplification. Root 48 I can express as root 16 into root 3, and root 16 is 4, so this is 4 root 3, and root 27 is 3 root 3. So root 3 will get cancelled out and I will left with minus 4. Okay, anyone has any doubt in this?
No, sir.
So,
No, sir.
No,
So there
sir.
are 4 rational numbers only.
No, sir.
Okay, so what are the rational numbers? The second one was 6, the third one was the rational number, and this last. Can you mute yourself if you are not talking here?
तुझे पता है ना फिजिक्स खाली फर्स्ट ईयर पे केमिस्ट्री भी नहीं रहेगी खाली मैथ्स रहेगी
Okay, fine. So yeah. Tell me.
My third one is rational. I don't get it.
Third one is just.
It is a irrational, na, sir.
next question, sir.
Because it's a non-equal.
there is no repetition.
Yeah, so third one is basically a finite decimal number, right? 4.879523. This is the third one. Are you
Sir,
asking
it
about
means
this?
finite decimals are rational, right?
Yeah, obviously finite decimals are rational because we can rationalize it. We can
It can
transform
be
it to the
told
rational
as
form. Right?
terminating number.
Yeah. When I am talking to someone, please don't interrupt, okay, in between. So this is basically, I can rationalize it, 487,952, and then the decimal for point, I can take 1, and for the numbers which are after the point, I can take zeros. That's how we transform it to the rational number. So this is rational. Any finite decimal number is rational number. Okay?
Sir, if this number is like a 1.333 and then that is rational or rational.
If it is ending at 1.333, then it is rational. But if 3 continues to infinite, then it is irrational. Okay, that's how it is. Okay, so there are four rational numbers, right, in this question.
Yes, sir.
Okay, great. Now, before moving to the second problem, we have defined what is complement of a set, right?
Excuse me,
So
sir.
there is something called, yeah.
Sir, I'm sorry, I just joined. Where are we doing these questions from?
No, so I am showing you some slides. You just take a pen and paper and you will solve the question and write in chat. Okay, I will
Oh,
take
thank
it.
you, sir. Thank you.
Have to join. Okay. So there is something called universal set. Universal set means from where we are taking all the elements, whatever set we are considering. Suppose we are inside the universe of natural number, then whatever the set we define inside, that will take the elements from the natural number. If we take our universal set to real number, then all our elements of different set will be real number. That's how universal set is defined.
Yes, sir.
Now, the elements which is outside of a set, that is basically complement of a set. Okay, and that's defined by a power c. So this is a complement. That's how it is defined. So if the black region is our set, then the outside white region is our A complement. If we take this rectangle as the universal set.
What is rectangular, sir?
So this is rectangular area is basically the universal set from where we are taking all the elements. Okay. Yeah. So now what is self subtraction? So this is suppose A minus B. That is basically all those elements which are inside A but not in B. Right, because there can be some element which is common in both A and B, that is basically intersection, right? A intersection B. So those elements which are inside A but not in the intersection of A and B, that is your A minus B. Right, is it clear to everyone?
Sir, if it's
Yes,
like
sir.
A minus B minus C, then how we can say, sir? If it is A minus B minus C, if there are three
No, for
sets
set,
A, B, and
yeah,
C,
so first you
how
have
you
to
can
define
say,
what
sir?
is A minus B, then from that set, those elements which are in A minus B but not in C, that's how it is defined. Usual one. Okay.
So only A, like that, only A, B, and C we can say, no, sir. If it
You
like
have to
that.
give parentheses, otherwise you cannot say. So if I write it here. So let me write it. So you are saying A minus B minus C. This means first you
Yes,
consider
sir.
this. Okay. Suppose I have this. This is A, this is B, and this is C. So what is A minus B first? A minus B is basically, if I point
Only A,
it
sir.
out,
Only A, sir.
this region, right? This region, correct?
Yes, sir.
This is our A minus B. Now, those elements which are inside A minus B but not in C. So I have to eliminate this portion. This portion I have to eliminate. I will. So this is my A minus B minus C. Only the red portion.
Yes,
Is it clear?
understood, sir. Yes, sir, understood, sir.
Oh, great. Why are you unmuting yourself if you don't talking here? Yeah. So this is what A minus B is. And union, all the elements together. Take all the elements of both the set A and B. And
Yes.
intersection, what is common in between those set A and B, right? That is called intersection. So yeah. Now there are some formula you have seen about the cardinality of a set, right? When you are calculating A union B, what we are basically calculating? We are calculating cardinality of A and cardinality of B, but when we are calculating, we have calculated intersection twice, so I have to eliminate once, right? So that is the first formula is saying. Is it clear to everyone?
Sir, can you once explain?
Okay. So let me draw this. So if I want to calculate A union B,
A union B.
the cardinality of A, so this is A, this is B, and this is A intersection B, the mid portion. Now I have to calculate cardinality of A union B.
A and B.
So if I take cardinality of A, then this is the cardinality of A, all those elements which are inside this region, which I have pointed out, plus B. Let's say B, if I point out like this. So this is MB. Now, if you see, I have calculated this region intersection twice while calculating A and while calculating B. So I have to subtract this once. So that's how the first formula has come. Is it clear?
Yes, I understood.
Sir, will these slides be uploaded on somewhere?
Yeah, this slide will be there in your portal. Okay. This slide will be.
Sir, one small.
Sir, I want
Sir, one more small request, sir.
Could be.
Sir, can you show us how to solve, sir, inside out set problem, inside out and outside in, sir?
Inside out, outside in.
I mean, some problems we have to start solving from the middle area, right? And
Right.
going after like solving then the two area common. I mean, sharing the two common areas.
Basically, that is what I am showing here. This is what you have to do, right?
And so then some problems are such from we start solving the like outside, like for example, the middle value is x, right? So we need to find out the x, sir. So how to find it like outside in, sir? So how to solve that one, sir?
So suppose this A intersection B is given, this cardinality is given, right? As you were saying, this is A x. You have to calculate it. Now you know the total A union B, the cardinality of that. Suppose it is 8. You know cardinality of A or you know cardinality of B. Then now can you solve x using this formula? Right? You can solve it, right? Are you there with me?
Okay. Yeah. Yes, sir. Yes.
Yeah. Right. So basically, that is what we are doing. So if you know the Venn diagram properly, you can solve any set problem. That is the beauty of Venn diagram. So suppose I have given you this thing.
So then how can A intercircle B, sir?
What?
Hello?
Yeah, tell me.
A union, so A union B, and this is a formula of what?
Cardinality of A union B.
Okay.
And how many?
Sir, I want to ask one question, sir.
Yeah.
Excuse me, sir. Sir, I am having a doubt that every one function is onto function or not.
I will come to that later. Okay. Now I am in set. I will go there eventually. Okay.
Okay, sir.
Okay. Now suppose if I want to find the cardinality of A minus B, this region. What is the cardinality of A minus B? How can we calculate that? If we know the cardinality of A, cardinality of B, and cardinality of A union B, can we do that?
Yes, sir, we can do that.
How?
Sir, it would be cardinality of B and cardinality of A minus cardinality of B plus cardinality of A intersection B.
Right. And anything else we can say more directly?
Cardinality of A minus cardinality
so
of
we
A
can
intersection
directly
B.
say that cardinality of A and cardinality of A is combined.
So if we know cardinality of A union B, suppose we know cardinality of A union B. Okay. We know this cardinality.
You can directly subtract the cardinality of A union B minus cardinality of A intersection B.
Directly subtract the cardinality of B from the union, right? Because union you have all these things. You just subtract this B part, and we'll get what is inside A minus B, right? So if you know the Venn diagram, you can create this formula on your own. There is nothing No one is preventing you to do that. Okay. Understood? How these are coming? So this is basically your Venn diagram, nothing else. Okay. So yeah.
Sir, I have a doubt.
Hmm.
That sir, I joined the previous session of 6 to 8, and I engaged with that there are 2 sessions, and I'm not able to take the second session.
What?
It was
Sir,
recorded channel, YouTube channel.
Yeah, everything is recorded. So the earlier session was from the TAs, right? And
Yes,
this
sir.
is the instructor session. So
And sir, how this course will go? How this lecture will go?
what does it?
What is the process of this lecture?
You are seeing all the lectures in the portal, right?
So what is the process? What you want to teach us about this lecture? About the about from lecture?
To become a qualifying exam.
No, I know. But what you are you summarizing that week?
This is a
So in this live session, I am basically recalling whatever we have done in week 1, and I am solving some problem.
Okay, sir, will you go for the questions?
Not today, because I have selected many questions today, so we will solve more or less that.
Okay.
And I will discuss the ideas, discuss the concept. Anyway.
Okay, sir. Okay.
Okay, sir.
Okay, so some of you may want to do this type of problem. I think you are asking this. So there are 3 sets, right?
Yes.
M, S, and C. All the cardinalities of the regions are given, right? 10, 40, 20. Wherever it is written, that is the cardinality of that region. So, can someone just tell me what is cardinality of M in this case before finding this cardinality M minus C?
10.
Can someone just tell me what is cardinality of M?
10 plus 40 plus 50 plus 70.
170.
Right. This is 10 plus 40 plus 50 plus 70. That is the cardinality of all these elements, right? So how much it is? 170, right?
170.
Yeah,
170, sir.
170, sir.
So that's how this diagram is working. Now we want to find what is cardinality of M minus C.
50.
50, sir.
50.
50, sir.
50, sir.
Right. So which region I have to delete? I have to delete this
70 and 50, sir.
Intersection between M and C.
Exactly. So only thing is which are inside M but not in C, that is 40 plus 10. That is 50. So cardinality of M minus C is 50. Is it clear?
Yes, sir.
Yes, sir.
So this region is basically M minus C.
Yes, sir.
Yes, sir.
Okay, great. So for the next one.
Sir, can you explain, sir, again the previous question?
So M minus C, which portion is M minus C? The region which is inside M but not in C, right? Outside C. So what are 2 numbers in those regions? 10 and 40. So that is the cardinality.
Okay, sir.
So for basically for 3 sets, it can be in the 3rd set also. The region can also be in the 3rd set.
Exactly. So I draw a diagram, right? Just a moment before this diagram I have drawn, right? So this is the same type of diagram we are seeing. Okay.
Excuse me, sir.
Yeah.
The white screen make a strain on our eye. Will you take the black screen from tomorrow?
Black screen, right?
Yes, sir. So because sir, this white screen make a strain on our eyes.
No, I am doing it on black screen. I mean, you are suggesting to take white.
No, sir, black.
So this is black, right?
Yes, sir. Previous slide is white.
So I cannot make. Yeah.
TBS is also in black, sir.
Okay, so this one.
Let's get back now.
M union C intersection S. Right? There are 3 sets, M, C, and S.
150.
So
110, sir.
150. Oh, bro, this is good, bro.
Black
150.
You focus on the problem, not black or white. Okay. So what is M union C first?
Sir, 150.
Whole set of M and D.
Exactly, whole of M and C. So if I just ask what is the cardinality of M union C, can someone tell me that?
70, sir. 70, sir.
110, sir.
260.
120.
200.
110, sir.
So how much?
260, sir.
260, sir.
M union C.
M union C, yeah, that is 40 plus 10 plus 50 plus 70 plus 60 plus 30, yeah.
260. 260
Ah,
minus
so all these
260 minus 150.
100, yeah, 100, 100, 200, 260. Now intersection S. So which question is it?
40 minus 150 plus 60.
40 plus 50 plus 60.
Union C.
40, 50, 60.
So
150,
let's
sir.
see what is the idea.
150.
This
150,
is the
sir.
idea. Yeah, yeah, I got it.
Intersection area.
150 is
Yeah, yeah, got it, got it, got it.
150.
This is 150. Yeah, okay, fine. So this is the region. The striped region is basically M union C intersection S. So 40 plus 50 plus 60.
Union C. Sir, start 130 minus.
You calculate it by yourself, then you will get. So 40 plus
Sir, I
50.
have a doubt. 80, sir.
Yeah,
M union.
Sir, I have a doubt. Can I ask?
yeah, tell me.
Sir, M union C, it should be 70-50 that shaded, no, only
No,
not
that
that
is
the tank portion.
intersection. You are saying about intersection, M intersection C.
Okay, wait,
M
sorry.
union C is the whole blue region.
Yeah, understood.
Okay, so that is M union C. All the elements of M and C.
Thank you, sir.
Okay, so this is 150. All of you are getting this. Okay. Now let's go to this one. So consider a set. This is how a set is written. A, all those elements coming from natural number. So
Less
natural
than
number is
3.
basically our universal set in this case. Such that A is less than 10. So what is S? Can someone just tell me?
That is 0 included in S.
0 to 10.
Time
0 to 10, including 10, right? Because A is less than
Natural
equal
numbers,
10.
yes.
So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is our set S. Now we are defining R1 and R2 like this. So what is R1?
It's in
R1
bullet.
is basically a pair x comma y, where x and y are coming from S, and the relation is y equal to 2x. How y is related to x? Y is 2 of x. That's how this set is formed. And what is R2? R2, y is x square, the square power of x. That's how R1 and R2 is defined. Now we have to find the cardinality of this set. So first, for solving this problem, first what you have to do, you have to write what is S, then you have to write what is R1 explicitly, and write what is R2. Then you can calculate R1 union R2 minus R2, then you can get the cardinality. So I am giving you 4-5 minutes to solve this. Okay, I want all of you.
The answer would be R1.
No, you have to find the cardinality.
Okay.
Right? Yeah. So write down R1, write down R2, and then find what is the cardinality of that. Okay. Yeah. So solve it. I will wait for 3-4 minutes. Then.
So what is the PFF code?
No, you don't have to join here. You don't have to join in PR deck. You just write your answer in chat.
Okay.
I am not using PR deck for taking your answers.
Answer is 3, sir.
Solve it. We'll discuss this. You check your answer. I think it is not correct. You have missed something.
Sir, 11, sir.
Not 11.
Sir, 1.
27, sir.
6, sir. 6 will be.
4.
Okay. Let's we will
4.
see.
4, sir. 4. 4.
You got 4. Okay. 1. Okay.
4. 4.
4, sir.
Okay.
4, sir.
Okay. Anyone wants to try? I have one. I can give you 1 more minute to do that.
Sir, just 1 minute, please.
Yeah. 1 minute. I am giving you 1 minute. Solving. Then we will start.
Sir, in case of relation R1, the only elements possible are 1, 2.
We will discuss that. Okay. Let others solve. Then okay. So now I am going to the discussion. Okay. So that is what I told you to do. So R1 is basically your x comma y, where y is multiple of 2. Right? So we should start with 0, 0.
6, 12.
6, 12.
I am coming to that.
A less than equal.
I am coming to that. That is not inside the set. So 0, 0 is there, 1, 2 is there, 2, 4 is there, 3, 6, 4, 8, 5, 10, then 6, 12. But what was condition? Condition was less than 10, right? So 6, 12 should not be there. So this is
Less than equal to.
right? Because all elements should be less than equal to 10. So how many elements are inside R1? 6.
6.
Okay, great. Now what about R2? R2 is x equal to y squared. Right? The power y equal to x squared.
4 elements.
Yeah,
4.
0, 0, 1, 1, 2, 4, and 3, 9. If we take 4, then the next element will be 16. So 4, 16 cannot be there. So there are 4 elements. Now what is R1 union R2? We should take all the elements. Right? How many elements are there in R1 union R2?
8 elements.
8.
Now if I just ask, what is R1 intersection R2? What is that say?
0, 0, 2, 4.
0, 0 and 2, 4 will come.
So there are only 2 elements in R1.
Only 2 elements.
Exactly. Okay. But that is not the part of our problem. So R1 union R2 minus R2. So I have to see among these elements, this 1, 2, 3, 4, 8 elements. Among these 8 elements, we have to eliminate those elements which are coming from R2. Right? So which element are inside R2? 0, 0 are inside R2. 1, 1, 2, 4, and 3, 9. These red elements are inside R2. So we should eliminate those. So how many elements will be left?
4.
4.
4.
4.
1, 2, 3, 6, 4, 8, 5, 10. Is it clear?
Sir,
Yes.
sir can explain
Yes,
R2,
Yes,
sir.
sir.
R2, sir. I didn't understand, sir.
Yeah, R2 is basically y equal to x squared. Okay. So second element should be square of the first one. So 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9. Now if I take 4, then 4 square is 16. But it should be less than 10. So we cannot take that. And
Sir,
after that we cannot take
Do we
any
need
other.
0, 0? Do we need 0, 0? It's
Yeah,
not
because
a natural number, right?
there are 0.
Sir, in R1, will 0, 0 will be included or not, sir?
Yeah, it's a natural number, right?
But we have to take the set
Yeah,
of
yeah,
x.
this is a
But it's
natural
not
number.
twice of the first number, right?
It is twice of the first number. What is 2 into 0?
Yeah, but it will be same number. So how it will
What
be
is 2
equal?
into 0? That is 0, right?
Yeah, it's 0.
So y equal to 2x means what? 2 into something
Acha,
should
2
be
into-
what?
Okay.
Yeah, that is what it is.
Can you open the question?
Huh?
Can you show the question of this?
Can you show the question, sir?
Sir, can you please explain the 2, sir?
This was the question.
Yeah, it says belongs to natural number. So natural number is from 1 onwards, right? 0 is not included,
No,
right?
no, natural number in
Yes,
in the past lecture. While I am talking, please, can you please mute yourself?
Yeah.
Okay. If I am answering someone question, first let me finish. Then if you have some comment, then you can give, right? Don't interrupt in between. So in this course, when we are starting with natural number, because we are doing a data science course, right? So it is computer oriented. So in computer science, we generally, so this is an axiom, we generally take 0 inside natural number. But if we only focus on mathematical portion of it, we generally start from 1. But as it is a computer science oriented course, here we include 0 inside natural number. That's how the convention is. So this is just a convention. So in our course, we are including 0 in our natural number. Remember that. Okay. Okay, fine. So this is what we have. The question was. So this is R1.
Hello,
This is
sir.
R2. Yeah. Tell me.
Can you please explain R1? I mean, set builder form of R1.
R1 means y equal to 2x. So second element should be 2 into the first element, right? Multiple of 2. So if we start from 0, what is 2 into 0? That is 0. What is 2 into 1? That is 2. 2 into 2, that is 4. 3 into 2, 6. 4 into 2, 8. 5 into 10. 5 into 2, 10. Then if we take 6, 6 into 2 is 12, but it is greater than 10, right? So we will not include that. That was in our condition.
We are multiplying natural numbers with 2 na every time.
Right.
So can you
but if you see the question from where we are taking the elements, a should be like all the natural number such that a is less than equal to 10 and xy both belongs to s. So if we take 6, 6 into 2, that is 12, it is greater than 10. It should not be inside s, right? So we should stop at 5, 10. Is it clear?
Sir, are we taking 0, 0 because we are assuming 0 to be a natural number?
Right.
Okay, sir.
Yeah.
Sir, I can you please explain the step 2, sir?
Yeah, I am coming to that. But first, who asked me this R1 question? Is it clear to you?
Yes, it's clear.
2,6 is belong to R1.
Huh?
2,6 is belong to R1.
2,6 is 6 multiple of 2. I mean, not multiple of 2. It's 2 into 2, 6. Because why should we 2 into first, right? That is not happening. This is the condition. Y equal to 2x. Right?
Okay, sir.
So can 2,6 belong to R1? No, right? The second element is not 2 into the first element. So it is not 2,6 cannot belong to R1. Yeah. So all the second element is the 2 into the first element. That is the condition here. And we cannot include 6,12. That is the condition. Is it clear?
Yes, sir. Clear.
Okay. Now someone
I have
was
a doubt.
asking about R2.
Yes,
Right?
sir.
R2 is basically the second element is square of the first one. So we start with 0. What is square of 0? 0. What is square of 1? 1. What is square of 2? 4. Square of 3, that is 9.
9.
Now square of 4, that is 16. Now again
16.
we exit 10. It cannot happen. Right? So we should stop there. So these are the 4 elements. Is it clear?
Sir, how
Yes,
come?
sir.
Sir, how come?
Sir, I have a doubt, sir.
1 minute. Yeah, tell me.
How come?
With R1, 5, 10, it will come exactly 10 means we can add, right? Otherwise, we should not add before
Because
we
there
should
was
stop.
there was less than equal to sign. So 10
Less
can
than,
be
okay, fine. Okay. Less than only means we should stop
Exactly.
before 10.
Exactly.
Yeah, thank you, sir. Thank you so much.
Yeah. Any other doubt?
Sir, no, sir.
No, sir.
Step
No, sir.
Okay.
Move to the next question, sir.
So step 2, sir. Yes,
Step
sir.
2. Yeah. So R1 union R2 means all those elements which are either in R1 or in R2. So 0, 0 is there. 1, 1.
1 is there.
So I am taking all the elements which are either in R1 or R2. So there
How
are
come
total 8.
1, 2? How come 1, 2?
1, 2 is inside R1, no?
Okay.
Union. I am taking union, not intersection.
Okay. Yeah. Got
All
it.
those elements. I mean, if it is inside R1 or R2, we can take inside R1.
Okay.
Okay. That is
Okay.
what. Okay, great. So this is the problem. Now, any subset of A cross A is basically, or A cross B is the relation, right? Now, there are different type of relation which we have studied. So first one, you can say that it is symmetric. When a relation is symmetric, if A comma B is inside a relation, inside a set R, which is a relation, then B comma A should be there, right? If A comma B is there, then B comma A must be there. That is then we can say that it is a symmetric relation. Okay. So if I see this example, 1, 2 is there. Then what element should be there to make it symmetric? 2, 1 should be there.
2,
And
1.
That is indeed there. Now, if I see the second one, 2, 4, then 4, 2 should be there. If I, in this set, if I delete 4, 2, is it a symmetric relation?
No, sir.
No, sir.
No, sir.
Although for the
Anti-symmetric,
first
sir.
element, when I am talking about symmetric, let's focus on that. I will talk about antisymmetric later. Okay. Suppose I have these first three elements 1, 2, 2, 4, and 2, 1. Although for 1, 2, 2, 1 is there, still it will not be symmetric because for 2, 4 there are no 4, 2. Right. So if I include 4, 2, then it will be a symmetric relation. Is it clear?
Yes, sir.
Yes,
sir.
Yes, sir.
Now, what about transitive property? Transitive property means
Yes, sir.
if A, B and B, C is in R. If both these are in R. Right. So the second element of the first pair and the first element of the second pair, if these two matches, then the first element of the first pair and third element of the second element of the second pair should be an element of R. Okay. So that is A, C.
Yes, sir.
So if this happens, then we can call it transitive relation. So let's see the example. 1, 2 is there. 2, 4 is there. So if I consider 1 as A and 2 as B and 4 as C, then what element should be there to make it transitive?
1, 2, sir.
1 and
4. 1,
that is
1,
that is
4.
yeah, that is there. Right. Okay. Now 1, 4 is there. Now again I am seeing 4, 2 is also there. Now which element should be there inside?
1, 2.
1, 2, which is already there.
1, 2.
Yeah, which is already there in the set. Okay. Now 1, 4, 4, 2 is done. 4, 2 and 2, 2 is there. Which element should be there? 4, 2 is there.
2. 4, 2.
Yeah, it is there. Anything I have to check? Anything else?
Yes, sir. Like for the first one, it was 1, 2, right?
Yeah.
And then it was 2, 4. So you said 1, 4 must be there. And what if we take the second pair and the third pair, 2, 4 and 1, 2. So 2, 2 would also be there, right?
No, 2, 4 and 1, 2 is this of the form A, B and B, C.
No.
The second element should match with the first element of the second pair, right?
Okay, yeah, right. Okay.
But still there are something left to check. If you see 2, 4, the second element, and 4, 2,
yeah,
then 4 and 4 is matching. Then 2, 2 should be there. Yeah, it is there. Anything else? Anything else is there?
I have one doubt. The symmetric property. So it is related to a set, or it is within this. For example, 1, 2. If there are two sets, 1, 2 and 2, 4. So if 2, 1 and 4, 2 is there, then it is symmetric. But is it with respect to a set or within this relation? So, for example, in the reflexive,
it's a property of a relation. It's property of a relation. So relation is also a set, right? Relation is basically a subset of Cartesian product. Okay, relation is also a set, and inside that set, inside that relation, we need this property to be symmetric. If A, B is there, then B, A must be there. Okay.
Sir, I have a doubt, sir. Only one element, that is 2, 3 is a transitive, sir. Only one element.
Yeah, it is transitive. Why? Can you tell me why? Why that is transitive? Because there is only A, B. There is no B, C pair. So we don't have to check for A, C. So this condition is aqueously satisfied. I mean, there are no such B, C. So what we will check? So it will be transitive.
So I just have a small doubt over here. Like you told, right, that if we should have B as the first element of the second pair, right? Then only we can, yeah. So there was a question, I think, in the AQ where it was, the set was snake, frog, fox, and snake, fox.
Let me write that. So that will be another example. So let me write that.
So it will
Sir, I
become
can't
reflexive
understand
also,
that
sir.
example of the transitive, sir. Example
Yeah?
of transitive, I can't understand, sir.
What?
So the example of the transitive, I can't understand.
I am giving you another example. Yeah. Tell me that
Yeah.
that example.
Yeah, it was snake, frog, lion, and the third one was fox, frog, and the fourth one was snake and fox.
Right.
So overhead was written that it is transitive. So I'm not getting
So
why
let
the
me ask. Okay. Let's discuss this.
Sir, this is transitive.
1 minute.
So
1 minute. Yeah. Okay. So if I take this first pair A B, any element starting from frog is there? Any pair which is starting with frog?
Sir, it is fox, frog.
What am I asking? Just answer that, na?
no, sir.
Is
No,
there
sir.
any element which is starting with frog? No, right?
No, sir.
No, sir.
Okay, great.
No.
For the second one, any element, so this is lion, lion. So if I take this as B, any element starting with lion?
No,
right?
sir.
No, sir.
Okay.
No,
For
sir.
frog,
No, sir.
any
Yes,
element
it is
starting
there.
with frog? Any element starting with frog?
No, sir.
Right? For the last one, this one, any element starting with fox?
Yes, sir.
Yes, sir.
Yes, sir. So what element should be there?
Snake and frog.
Snake and frog.
And is it inside all the set?
Yes, sir.
It's already inside the set.
Okay,
Anything
sir.
else
Sir,
we are left? Anything else we
sir,
are left?
lion will become reflexive, no, sir.
No, for reflexive we need all such pair, all such A comma A, which is
So, sir,
inside the set.
They are
okay.
like cousins.
So if there, but sir, there is no lion include. There is no another pair that the lion included, sir. Lion is left off the.
That doesn't matter. For reflexive, all such pairs. Suppose our original set is snake, frog,
Frog, lion,
and fox.
and
Suppose these
fox.
four elements. Then for
Okay, sir.
the relation to be reflexive, snake, snake, frog, frog, lion, lion, fox, fox. All these four should be there.
Okay, sir.
At
For
least one is
transitive, sir,
then we cannot take.
for semantic, sir, if there is snake and snake, there is no lion and fox, and it's okay, sir.
Yeah. So snake and frog is there, but frog, snake is not there.
So this is not transitive either, because it only one
this is
element, alone as the transitive, right? For it should satisfy for everything.
No. Whenever A comma B is there and B comma C is there, then only we need B comma C. This is whenever condition. Whenever these are there. So whenever this
A comma.
so B comma C is there, right? Fox comma frog and snake comma frog. These two elements are there. So snake comma frog is there, and that is already there. So it is transitive.
Sir, if there was a frog and snake, it would become the symmetric, sir. Frog and snake, if it was there in the relation.
Frog and many other elements should be there. No, fox comma frog comma fox should be there. Fox comma snake should be there.
Okay.
All this should be there. Okay.
Sir, only for the reflexive relation, all the elements from A to B should be there, or for the symmetric, the condition is not applicable. All elements.
Exactly. For transitive, it is not applicable, now, sir. All elements should be there.
Suppose I have these three elements. First, tell me, is it reflexive?
No.
No, sir, because CC is not there.
Which element? Yeah,
C is not there.
CC is missing. So it is not reflexive.
Okay,
is it transitive? Is it symmetric?
No, sir.
No.
No, sir.
Why?
Sir, it is not transitive, but it is symmetric.
B comma.
Yes,
B
sir.
comma A is not there.
B comma A is not there.
And B comma is.
It is not there. But A comma B is there, but B comma is not there. So it is not symmetric. Okay?
Okay.
So if there was a B comma A and there was no B comma C and C comma B.
I will give you example. No, first, let me do this. Is it transitive?
Yes, sir.
No, sir.
Yes, sir.
Yes, sir.
Okay.
No,
So
sir.
any element starting with
No,
A?
sir.
Yes, sir.
No, sir, it is not because of BB.
No, sir.
It is.
Sir, it's a
Because there is no
transitive.
third element, sir. There is no third element. C.
Comma
Let
C,
me
For
A,
we need
comma
A
C.
is
let me
not
go one by
there.
one.
Yes,
Okay,
sir,
fine,
it
fine.
is.
There are only two elements, sir.
Okay.
That
That's
transitive, sir.
very, I mean, when someone is talking, I mean, why everybody is talking at the same point? Okay, let's first start with A comma A. Okay. Any element starting with A? Yes, there is. That is A comma B. So this element is common. So our element should be A comma B. Right? If this is A, this is second element is common with this one. So first and third element should be paired, and that is inside the R. So this is okay. This is fine. Any element starting with B? No, there are no other elements starting with B other than this. So I can take A comma B and B comma B. This is also happening. Right? This is the second element. This is the first element. These two are there. If I combine this, A comma B should be there, which is already there. Yeah, obviously. So our transitive property is satisfied for all the elements. So it is transitive.
Transitive, sir.
Sir?
Clear? So it is not.
Can you explain that one second, please?
Yeah.
Sir, one. If you explain with a number, sir, number.
That doesn't matter. Instead of one ABC, you take 1, 2, 3.
Because sir, if
Same.
there was a 1, 1, the second element should be different from the first element, sir. If there was.
So what? No, I mean that A comma B is not different element. These are just positioning. These are just notation. Okay. That does
Explain the
not mean
second
A
one,
and B
sir.
are different.
Is there any element starting with B? You said that second part. Can you explain the second part again, please?
So there are elements starting with B, this one, right?
Yes.
So this is what element I have taken. A comma B and B comma B. So this is the second element of the first one. This is the first element of the second one. They are matching. So first comma third should be there. That is A comma B. And it is indeed there, obviously. A comma B. That's what we have started. So this is transitive property is holding for every element.
It's not the reflective.
This is not reflexive, not symmetric, but transitive.
Okay.
Is it clear? Let me give you another example.
Sir, it is transitive.
It is transitive. So let me
Sir, I
take
have a
same A
data.
comma B. Okay. Now let's talk about this. First of all, tell me, is it reflexive? That checking is easy. Is it reflexive?
No, sir. No, sir. It is not reflexive.
Not reflexive.
Not
No,
reflexive. Because B
reflexive.
comma B and C comma C is not there.
reflexive, sir.
Not reflexive.
No, sir, not reflexive.
Yeah, okay, understood. Is it symmetric?
No, sir.
No, sir.
Not
CA.
No, sir.
C comma A is
BC not there.
Comma C not there.
C comma is not there. B comma C is not there. So it is not symmetric. Is it transitive?
Symmetric, sir.
Yes, sir.
Yes, sir. It is transitive.
Yes,
Yes.
sir.
Okay. Now let me explain. Okay. So first,
Sir, I just said it is not transitive.
let me explain now. Okay, I understood.
No.
So if A comma A and A comma B is there, this is common. Which element should be there?
A comma B.
AB, sir.
Yes, it's there.
It is there. Now A comma B and B comma A. This is
A
common.
comma A.
This is there. Correct?
Yes,
Okay,
sir.
great. Now next, what is that? B
A.
comma A comma A. If I take
B
this
comma
third
C.
element and first element,
B
I am
comma
going
A.
one by one. Third and first.
Comma, yes, sir.
This is B comma A. It is also there. Great. Okay, so these are done. B comma A and A comma C. Which element should be there?
B comma C.
B comma C, not there, sir.
It's not there.
Not done.
Not right.
Is it clear? Is it clear?
Yes, sir.
Yes, sir.
But again, if you see the last two pair, A comma C and C comma B, which element should be there?
A,
B is there, but this element is not there. This is not happening. That's why it is not transitive. Is it clear?
Sir, I have one doubt.
Yes, sir.
So the pairs are taken like in a linear fashion, like A, comma, to the two at a time, right? So what if you get the last element, so you have to go back to C, comma B and A, comma A? Or is it based on
all
that?
combination? You check for all such combination.
Okay.
Like how I am doing. I'm just listing all the element, right? So you have to check for all such pair, all such combination. Okay. Yeah.
Okay.
So, sir, you for reflexive and symmetric, you told that every element should be included, sir. In last, that line was not included in transitive, sir. It's okay, sir.
What? What? I have not understood the question. What?
Means for reflexive, sir, if there is a comma a 1 1 2 3 1 1 2 2 3 3 should be there for reflexive,
Should
sir.
be there, right.
For symmetric, sir, 1 2 and 2 1 should be there. 1 2 and 2 1 is there, sir. If there is no 2 3 and 3 2, if it's
That
okay,
is
sir.
not. That is not what I am saying. So if we say this one, 1 2 2 1, say 1 3. Okay. If I take this relation over this set, first tell me, is it reflexive?
Yes, sir.
Yes, sir.
Yes, sir.
No, sir.
Yes, right? Because 1 comma 1 is there,
Yes,
2
sir.
comma 2 is there. Okay?
Yes.
Fine. Is it symmetric?
No.
1 comma 2 is there, 2 comma 1 is there, that is fine.
All right.
But 1 comma 3 is there, but 3 comma 1 is not there.
No,
Right? 3 comma 1 is not there. So it is
Not symmetric, sir.
not symmetric. Is it clear?
Yes, sir.
Okay, great.
Yes, sir.
Sir, if you not wrote the 1 comma 3, it would be symmetric, sir. If
It
you are
would be
not
symmetric.
written 1
Correct.
comma 3.
Yes,
Correct. Understood, no?
So, sir, if you not consider if is in the set of the
See,
all
there are
elements, if you not
infinitely
consider
many examples. Now you have understood the concept, right? Now you can do on your own, I think, right? Is it
Yes,
clear?
sir.
So,
I mean, this can go on. You eliminate one, you put another two. These are many examples you can create. But you understand the concept how we are doing it. Is it clear?
Yes, sir.
Just to reconfirm,
It is clear.
if the 1 comma 3 is not there, then it is
Then it
symmetric,
is
right?
symmetric. Yeah, right. Is it
This is not
transitive?
a transitive.
yes, sir, transitive.
No,
Yes,
sir. No, there is no 3 comma 1.
Do you need 3 comma 1? Why we need 3 comma 1?
Last 2
3 is
elements,
not
sir.
there. 2 and 3 is not there, that's why.
2 comma 1 and 1
2
comma
and
3.
3.
1 3 is not there, sir.
1 3 is there, no? This is there.
3
Oh,
comma
yeah,
1
okay,
3
okay.
are not there.
3
Okay,
comma 1
okay.
is not there, sir.
Okay.
It is not transitive.
This one, no?
3 2 and 2
This
3 is
one.
not
Take
there.
this one. These two are there. So this is common. So 2 comma 3
No,
should
sir,
be
not
there, but it
transitive,
is
sir.
not. Yeah. Understood.
Don't
So this
scare.
is
Don't.
not transitive. Okay.
Hello, sir.
Is it clear?
Hello, sir.
Yeah.
Sir, this is transitive. 1 comma 3 comma 1 is not present. We can say that this is transitive.
This is not transitive, no?
Sir, why?
2 comma 1 is there, right? This
Okay.
is what I have said. No? 2 comma 1 and 1 comma 3 is there, right? This is there.
1
So
comma.
1 is 3,
Okay,
1
okay.
comma 3.
2 comma 3 is
So
not
2
present.
comma 3 is not there, so it is not transitive. Okay.
Okay, sir.
You have to be careful with this, right? You have to be careful with this.
Okay, sir.
Okay, great. So this is what we needed. So I think more or less you understood the different type of relation, right?
Yes, sir. Yes, sir.
Yes, sir.
Okay, great.
Yes.
Great. So let's go back to our question. I think I can skip this question. Okay, let's do this. So there is a relation, right? A and B, where A and B lives in same city. Two people are related if they are in same city. They lives in same city. The question, the statement is, this is a symmetric relation. Is it true or false?
True.
True, sir.
True, sir.
Yes, sir. True,
If
sir.
A and B are living in same
Maybe
city,
they
B and A also live in
And B
same
and
city.
A lives in the same city. So
Exactly.
That's true.
this relation is a symmetric relation.
Yeah, understood. It's symmetric. Great.
Reflexive and
Now, is it transitive? The same relation?
Yes, sir.
No, sir.
Is it transitive?
Yes, sir.
It is transitive.
yes,
Because if A and
it
B
is.
are in same city, B and C are in same city, then A and C are also in same city.
Right, sir.
Yes,
Two
sir.
people are in
Transitive.
same city and second person and the third person is in the same city. The first and third person are in the same city.
Sir,
This is true. Yeah.
sir, last time you not took the
1 minute. Now ask. Tell me. Yeah, tell me. Any doubt?
No, sir.
Okay, great.
Please continue.
Okay, great. So this is done. Now we come to function. So till relation we have complete. Now we'll start with function.
Sir, I have a small doubt, sir.
Yeah, go ahead.
Sir, B element should be unique, na, sir. If there was no unique element, it could not become transitive, na, sir. If AA is there, sir.
So
If
you are saying
A, B, C,
so
we
you are
should have
saying
to
like
take three variables, na, sir.
1 minute. Suppose your set is this, right? And your relation
Then
is
only it could become
just this. Is it
no,
transitive?
Sir, no, sir.
It is transitive.
It is transitive, sir.
It is transitive. What transitive relation is saying? If two such pair exist, then we have to check for this. If this is not satisfied, then it is obviously transitive. I mean, then there is no point of checking this.
Sir, last example you took, na, sir. If A, B, and C lives in the same cities. So A is the same person, na, sir. A is the same person, na, sir. A cannot live in same city. If we can write A as in single.
Transitive. I am talking about transitive. If there are two people, okay, say two people, any name, say Shayan and Arijit. They live in same city, okay?
Yes, sir.
So they are related. And Arijit and say Sneha, they are related. They are also living in same city. So does not Shayan and Sneha live in same city?
Right, sir. But sir, if you consider Cyan has A, if you AA is if you write Cyan lives in the same city, na, sir.
Okay.
Let's put
so
Cyan. Okay, Cyan lives in.
I mean that doesn't matter. I mean this is for any general I am talking about. If
Okay,
A
sir.
and B
Okay.
lives in same city and B and C live in same city, then A and C must live in same city, right? Whatever ABC are, right?
Okay, sir.
Whatever ABC are, that doesn't matter.
So we can take same numbers 2 times, no, sir?
So
no problem.
that doesn't matter actually.
Okay, sir.
A, B can be repeated. I mean that doesn't matter. That is what I have said.
Okay.
Sir, if there is only set of A and C element, it's also transitive, right?
So suppose you are saying it's only two elements, right? A and B. That's what you are saying, is it?
Yeah.
And what is your relation? Suppose A, B, A, B, B, A. Suppose this is your relation. Is it transitive?
Yes, sir. Yes, sir. Is it the transitive?
Yeah, it is.
Yes.
It's transitive, right?
Yes, sir.
Yeah. Were you asking this?
No, sir. Not. Sir.
Yeah. Okay, good. Yeah. So this is transitive because all combinations are there, right? A, B, and C there. Even if I remove this one,
right?
Is it transitive still?
No, sir.
Why?
Because
transitive.
it's
I asked about transitivity.
It is
It is transitive, right? Because AB and BB. So which element should be there? This is common. AB should be there.
AB
Which
should
is
be
there?
Yes, yes.
AB and if AA. So if I
Then
take this one,
this
So can you just explain with a number example? Like, for example, if you have 1, 1 and 1, 2. So that is transitive, right?
so you are saying 1, 1 and 1, 2.
Yeah, 2 order pair. Yeah. So it is transitive now because we have
It's
A,
transitive,
A.
right?
This is transitive.
Yeah.
It's,
Okay.
This is nothing but say taking AA and AB, right?
Right. Yeah. Okay.
And what is the for transitivity? What is required? This
AB
all
and
common. So 1, 2 should be there, right? This is
right.
A, this is B, this is B, this is C, right? If I take
Yes.
like this, right? This B is common. So A comma C is basically 1, 2, and that is
Yes.
already there.
Okay. Yeah. So we don't repeat it anyway. Yeah. Okay.
So this is obviously transitive.
Okay.
Clear, no?
Yes.
Yes. Clear.
Okay, great. Okay, now let's just move to function. Yeah.
The functions.
Yeah, let's go to functions. So function is basically, it can be treated as a machine. So let me draw a diagram here. So what function does? It is taking an input and is giving us output. Don't sing, no? Yeah. So it is taking some input, it is giving output. Okay. And one input cannot give two output. Okay. Suppose we have two set like this. There are some elements. There are some elements. So this cannot happen. If I take this as input, I cannot get two output. This cannot happen. If this happens, then this is not a function. One input cannot give two output. One input cannot give two output. Or two or more. Okay. Two or more output. Okay, so this is the first condition. And second, every element of this side, every element of this domain, this is called domain, from where we are taking the inputs, this is called domain. Every element of the domain must have an image. I mean, every element should go somewhere. Okay, every element must have an output.
Sir?
Yeah.
Have an image or must be put to the connection? Have a connection or image?
What?
Sir, from input domain, have a connection or image?
Image.
What does it mean? And connection means what? I mean, I am just drawing this thematically. So this is the diagram, right? This is the input, this is the output. That is what you are doing with the function.
Sir, I learned in 12th class that you take an image in every image in codomain should be mapped with the domain.
No, then it is called onto function. Otherwise, it is not. Okay.
Okay, sir.
So suppose, let's take an example. R to R. You know what is R, right? Set of real number. I am taking this one. So what is domain? First, tell me what is domain in this case. Domain of it.
It might be any real number.
Any real number, right? All the real number. All the real number. This is the codomain. Codomain means what? Where all the output lies. Right?
Lies,
right.
Right.
Where we are expecting the output. Where we are expecting the output. Okay. Now, what is range? This is something different. Range is set of all output.
Set of all.
Range is a subset of codomain, sir.
Yeah, I'll come to that. Set of all output. So, codomain is where we are expecting the output, and range is which is sitting inside that.
Connected.
Right? It's sitting inside that. So, this is your domain. If I draw that thematically, this is domain. This is your codomain. Function works like this. And suppose this is your set of output. This is your range. So, all elements are mapping Yeah. This is the diagram we are talking about. Okay. Now for this function, what is range? Can someone just tell me? Is every
It's all
real number
positive only.
can be an image? Can be come as output every real number?
No, sir.
No,
No,
sir.
sir. Only positive.
They are
Only positive.
Positive natural number.
Positive.
Only not natural number, only
R plus,
positive
sir.
number.
R plus, sir.
Yeah,
It
only
is
positive
square
number. No negative number can be any negative number can be
Square.
output, right? Suppose I take -2, it cannot be an output of this function. There is no input
Nice.
for which I will get -2 as an output. Because if I take square of a real number, it is always positive. So our range is set of real number which is greater than 0. Right? All such real number such that x is greater than 0, greater than equal to 0. So this is inside R, this is inside the codomain, but this is not the whole codomain. Is it clear?
Yes.
Yeah.
Yes.
So you can there is a distinction between range and codomain, right?
Yes.
So there is a distinction.
Yes, sir.
Yeah. So this is what function does. So now let's go back to slide and see a little more. So this is what I have said. I will come back to later. Now this is how function. So suppose I give you a player's name, okay, any name of a player, and what my function does. Function tell me what is the name of the team. Okay, what is the name in which team they play. Suppose I say Virat. So Virat is Indian player. So Virat is mapping to India. Rohit, he is also playing for India. Rishabh Pant is also playing for India. But Root and Butler, they are coming from England, right? So they come from different, they play for different teams. So that's how function works. So you, in this case, you observe that many elements can go to a same element. That can happen. But one element cannot go to two different elements. I mean, Virat cannot play both for India and England. That can never happen. Right? So this is the function.
It's like that. Codomain can have two different pre-images, but pre-images cannot have two different images. No, sir.
That is Magendra's own. Is not.
Image can have a two.
Yeah, image can have different pre-images. That can happen. Yeah, right.
But pre-image cannot have a different images.
Right. Yeah. So now there are two types of functions. One is one-to-one function.
Injective, sir.
This is called injective. That is called onto function, which is surjective. I will come to that later.
Surjective, yes, sir.
What one-to-one function does? So I say, suppose there are
one-to-one function. It could be variable or not variable, sir.
What?
No, one-to-one function. It could be variable or non-variable. The range
What
of the so it's range of the function I'm asking, sir. Injective. It could be the variable or not variable.
What does variable and not variable mean?
The variable in sense that if the two sides is there, right? The functions I am asking, the range of the function, yeah, the range of the domain, it should be the variable
range
or not
of
variable.
the domain and range are two different sets.
Okay.
What is range of the domain?
The domain is a value. It's a value.
Let's hear that. You hear my statement, then you can ask. Okay. I think that will be clear.
Yeah, yeah.
So
that
this
one.
is your codomain.
Yes,
This is your domain, and this is your codomain. Okay. Now, for one-to-one function, suppose this element is there going there, and this element also going there. This element going there. This is how the function works. This is not one-to-one. Why? Because there are two elements inside the domain which are going to the same image, which are giving me the same output. This cannot happen for one-to-one function. If this type of situation happens, then it is not one-to-one function. Otherwise, it is one-to-one. So let me give an example to make it clear. Suppose if R to R, fx is x plus 2. Okay. And take another example, R to R, which I have taken earlier, fx equal to x square. So take the second example first. What is the image of 1? What is the image of 1?
One.
What is image of minus 1?
1.
1.
So there are two elements inside the domain which are going to the same element, right? Yes. So this function is not 1. Yeah.
Okay. Okay. Very clear, sir.
So can you please describe it again, sir?
For being not 1 to 1, what is required? I mean, if two element of the domain is going to the same element. This is same element. Okay. Whatever the sign is. If two element of the domain is going to the same element, then the function is not 1 to 1. Okay. What does it mean? For this fx equal to x square, what is the image of 1? That is 1. Right? 1 square is 1. What is image of minus 1? That is again 1. So both 1 and minus 1 is going to same element. 1.
Yes, sir.
So this is not 1 to 1 function. Clear?
Okay, sir.
What the function is called, sir?
There is no name. This is not 1 to 1 function. I mean,
Okay,
it is
sir.
not 1 to 1.
Okay, sir.
It is not injective. Not 1 to 1. Not injective. Injective and 1 to 1 is basically the same thing. Okay.
Sorry,
Now, what about the first one?
anyone?
What about the first one? X plus 2.
It is 1 to 1.
It is 1 to 1 because suppose, so let's describe this function. R to R. Suppose there are two elements which is going to the same number. Suppose I am giving two elements A and B which is going to same number. So this should be equal. And what does it mean? It means A should be equal to B. So there cannot be two different elements. So A and B cannot be different if they have to go to the same element. They only go to the same element when the element is fixed, element is same. When A and B are equal, then only the output will be same. Otherwise, the output will never be same. Right? So
So
this
it is
function
1 to 1
is
only, no, sir?
1 to 1 function.
It's
Okay,
1 to 1.
Clear?
Yeah, it's good, sir. Function is clear.
Okay. So 1 to 1 is clear. Then the next thing is surjective or on to function.
ശ്രദ്ധിച്ച് കേട്ടിരുന്നൂടെ ചെറുന്ന് പറഞ്ഞാല് ഇവിടെ ഇരുന്നൊക്കെ കേട്ടൂടെ
Okay. Surjective function. So what surjective function is? So I have said.
Sir, I have a doubt, sir.
Yeah.
Sir, f of x is equal to x square, no, sir. So it can be onto, no, sir.
I have not said what onto is. Still.
Okay, sir.
Let me tell, then you can ask your doubt. Okay. There is something called codomain. Yeah. Now, I have said set of all images, set of all output is basically your range of the function. Now, range is always sitting inside codomain, right? So range is subset of codomain. That is always true. We call a function onto function if range and codomain is same. What does it mean? Every element of the codomain can be thought as an output of the function. You can get as an output of the function. What does it mean? Suppose you take this example. This one. So what is codomain here? This one. Codomain of f is real number, set of all real number. Can we get any real number as the output of this function?
Yes.
Yes. Suppose I want root 2. Root 2 is inside real number, right? I want root 2 as an output. What my input should be?
2 minus root 2.
Root 2 minus 2.
2 minus 2. Yes.
If I take root 2 minus 2 plus 2, then it will be root 2. Okay. So, any real number we can get as an output, because if I want any real number, say a is a real number, I want a as an output. My input should be a minus 2. Then I will get a as an output. Right? So any element of the codomain we can get as an output of the function. So here, what is range? Range of this function is
Equal to the
because
codomain.
any real number we can get as an output. So range and codomain are equal. So this function is on. Is it clear?
Yes, sir.
Yes, sir.
If we see the earlier example, fx equal to x square. This function. Codomain, this one is codomain.
Not on.
Not on.
What is the range of this function?
Natural numbers.
All the positive.
Square
He's
of
saying
natural
range is
number.
natural number. Why?
Natural numbers.
No, why natural number?
Square of
Any
natural
real number which is positive. That is your range. Not only natural number, any real number which is greater than equal to 0. That is your
X is equal to.
Okay, any real number is greater than 0. This is basically R plus. We denote it by R.
Square of, sir. Square of also.
So can we get after squaring in decimals
Square.
also?
Squaring.
Yeah, you can get you take any positive number, you take square root of that. So suppose a is your positive real number, any positive real number, R plus. Your input should be square root of that. That is a real number, no? That we don't require the domain to be natural number, right? Domain is real number. So root a, that is a real number. Whatever, that can be irrational also. That doesn't matter. What is happening here? This is it.
Excuse
Is
me,
it
sir.
clear?
Excuse me, sir.
Yeah, tell me.
Sir, if we put any number inside the domain, then there must be a square number or not?
No, that doesn't matter. No. That doesn't matter. Suppose 5. 5 is a positive real number. Can we get 5 as an output of this function?
Yes, root 5. Okay, sir.
Root
Fine,
5,
fine.
yeah.
Fine, sir.
F of root 5 is 5 because root 5 square is even. I mean, can we get root 2 as a output?
Yes, sir.
What is that?
2 raised to power 1 by 4. 1 by 4. Yes, sir.
This is also a real number.
Yes, sir.
So we can get any real number, any positive real number. So only problem is with the negative real number. That we cannot get.
Okay.
If I take -1, I cannot take any a for which a square is -1 because then a will not be a real number.
Yes, sir. Complex.
Right? Yeah, it will go to complex, no complex, but we are not going there. But it is not real number. That is what we know. Okay. So here range and codomain are not equal. Right? Range is this one,
yes, sir.
The subset of codomain. Here range and codomain are not equal.
Not on 2.
So it is not on 2. Is it clear?
Yes, sir.
Yes, sir.
So this is what onto and one-to-one function is. Right? And if a function has both this property 1-to-1 plus onto, if it is both.
Bijective.
Bijective.
Yeah.
Bijective.
Yeah. Okay.
Sir.
So let's go back to the slide.
Sir.
Yeah.
Sir, I have a doubt.
Yeah, tell me.
Sir, what about into function, sir?
There is nothing called into function.
Sir, but we are.
Where have you heard that into function?
Sir, we have learnt in our syllabus.
There is nothing called into function. Okay.
Injective is into, I think.
No. I have never heard that. I mean, I have never heard that terminology.
Okay, sir. It's okay.
Yeah. So this is a function. Okay. Natural number to natural number. And whenever n is odd, our function is going to n plus 1 by 2. And whenever n is even, our function is going to n by 2. So suppose I tell you what is f4. Can someone tell me what is f of 4?
2.
2. Yes.
I
divided
so
by
4 is
2.
even number. So 4 divided 2, it is 2. If I say 5, then it will take the
3.
upper one.
3.
5 plus 1 6 by 3. Yeah, right. Now the question is this function one-to-one function?
No, sir.
No, sir.
No,
Never mind.
No, sir.
Saying no,
No, sir.
then tell me two element from the natural number which is going to the same natural number.
No, sir.
Can you give me?
1 and 2.
3 and 4.
F1
sir.
equals to F2.
1 and 2.
1, 2.
Okay, there are many actually. Yeah, fine. Suppose f of 1. What is f of 1? 1 plus 1, 2.
1.
2.
1, sir.
What is 1?
1.
And what is f of 2?
1.
What is again
1.
1, sir.
of them are going to the same number. Yeah. Is it clear?
Yes, sir.
Yes, sir.
Yes.
Okay. What about 3 and 4?
3 and 4.
Again, same, sir. 3
Same,
plus
Same, sir. Same, sir.
Same, sir.
Same.
Yeah.
It is not 1-to-1. Then what kind of function is this? Is there any name regarding this?
No, there is no name regarding that.
Sir, that can be on 2.
This can be on 2, but we have to check it whether it is on 2.
Many one, sir. Many one.
Yes, sir,
Many one
because
is
it is
different
the
thing. I mean, many one cannot be that. Many one is basically coming from trigonometric functions. That many one property. But we are not really discussing about those now. Many one.
Okay, sir.
Okay. That is
Sir,
different.
it is-
I don't want to confuse many of the students, so I don't discuss that now.
Okay, sir.
Okay. Many one is basically regarding trigonometric function. That is not very good term to use, many one function, because many one gives the sense that many element is going to one element, but that is not a function, right?
Okay, sir.
That is not a function. Yeah.
Excuse me, sir.
Yeah.
Sir, I want to add something that there exists into function also.
Okay.
That it is mostly same like one function, but there is one more condition that at least one element of codomain remains unmatched with the domain. At that point, that function is called into function.
But we don't have it in the syllabus.
So
Why do we
basically, you are saying a function which is one-to-one but not on-to, right?
Yeah, a kind of.
Injective, sir.
So generally, we don't call it into function. You may have seen this name somewhere, but this terminology, believe me, this is not popular terminology in math world. Okay.
Okay, sir.
We generally tell this is one-to-one but not on. This terminology is we generally use in math. Math, you can see any math article or anything, you will get this terminology, not into. Into, we never use that. I mean, I have never heard about that. Right.
Sir, I have a confusion regarding. Sir?
Yeah.
Sir, n value is an x value, na, sir? Domain values are the n values, na, sir?
I mean, you can use n, x, m, a, b, anything. That doesn't matter. Right?
Sir, and sir, and we should have to get same number, na, sir? What I could not understand. If you draw the function for this, sir,
for what? What we should have to
n plus 1 divided by 2, sir, for this question.
What are you asking? I am not getting what.
Map. I want to see in mapping, sir. How can we map this to check on one?
What is image of 1? Tell me what is image of 1. What is image of 1?
It's not 1-to-1, sir.
1, 1.
What is image of 1?
1.
1, sir.
It's 1, sir. Yes, sir.
It's, right. 1 is odd. So 1 plus 1 by 2. Right. So it is 1. What is image of 2?
1.
1.
2 by 2. Right. And 2 is even. So 2 by 2 is 1. Right. So 1 and 2 both are going to the same element. So it is 1 to 1, not 1-to-1 function. Is it clear?
Right. So.
Yeah. Okay. Great. So this is what is written here. I am skipping it.
Okay, sir.
Another function. When n is odd, now n natural number to real number. Okay. So in when n is odd, then this is root n plus 1. N is even, then it is root n. Now again the question is can you please look again whether it is 1-to-1?
No, sir. No 1-to-1, sir.
No 1-1.
Why?
No 1-to-1, sir.
Because F1 equals to F2.
F1 equal to F2. Yeah, you are correct. So F1 is what? Root 2, right?
Root 2 and F2 is also root 2.
F2 is also root 2. Is it clear?
Yes, sir.
This is
Yes.
not 1 to 1.
Not 1, 1, right?
Yeah. What is F of 3?
F of 3 is 4.
The 2.
Root 2.
Two,
Root 1
sir.
means 2.
F of 3 is 2. F of 4?
That is also 2.
2.
What is 2?
This is also. Okay, great.
Not 1, 1.
So this function is clearly not 1 to 1 function.
Not 1.
Is it clear to everyone?
Yes, sir.
Yes.
Yes,
How,
sir.
sir? Yes, sir.
Sir, I didn't
Sir,
understand.
how,
How is it not 1 to 1?
Have you heard what I have told for the last 2 minutes? What is F of 1? Can you tell me?
Root of 1 plus 1, which would equal to root of 2.
Okay. What is F of
And
2?
if it is f of 2, sir, it would be again root of 2. And root of 2 is equal to root of 2. So how can it not be 1 to 1?
That is the definition of not being 1 to 1.
Sir, I am able to understand,
2
sir.
element. Huh?
Many to
Sir,
1.
sir, now it's clear, sir. Not 1 to 1.
Not 1 to 1, right. So basically, 2 element, if there are 2 elements which is going to the same image, then the function is not 1 to 1. Okay. So for 1 and 2, we are getting the same image. So the function is not 1 to 1, right?
Sir, this same question can be onto, sir.
I will come to 1 to later. Is it clear to everyone that this
Yes,
is
sir,
not
clear.
1 to 1?
Yes, sir.
Yes, sir, clear.
Yes.
Okay, great.
Yes, sir.
Sir.
Yeah.
Yes, sir.
Okay,
Yes, sir.
great.
Yes, sir.
So, yeah, fine. Now, someone is asking, is it onto? Suppose I ask, is this onto? Onto is little bit difficult for this, but still, let's try. Is it onto function?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Before, why
Yes,
you are
sir.
saying yes?
Yes, sir. This is
You
on.
have to explain why you have said
Because
yes.
So that
Sir,
is the
every
Range
domain
is
has a
equal
codomain.
Ah,
Codomain is
Real number.
No,
And
sir,
range
not
is
equal.
Condomain are different.
Range and
So you are saying, what is codomain of this function? So, okay.
codomain. Real number.
Real numbers.
real number.
Real numbers.
Let me write this. Okay, 1 minute.
This is not onto.
No, sir. It
Yes.
is not onto.
The coordinate
Yes,
of
sir,
that
not
function,
on.
sir.
Because of
You have
not
said
getting-
your answer. Some of you are saying yes, some of you are saying no. So let me do this. Okay. So this is what the function does, right? This is n odd. This is n even. Okay. Now let me explain that. What is codomain of the function? Real number. You have said, right? This is the codomain.
Yes, sir. Yes, sir.
Now, if every element of codomain has a p-image, I mean every element of a codomain can be an output of the domain element, right? We can have that. So suppose 1 is inside real number, right? 1.
Yes, sir.
Yes, sir.
Can
Yes,
1 be an output of this function?
No, sir.
Yes, sir.
Yes, sir.
No.
What is the
No,
image?
No, sir. No.
No.
It can.
No, sir.
It can or it cannot. What? So
Sir,
let me
root 2
ask.
is the correct.
No. First, tell me, can 1 be an output of this function?
No.
That is
No,
the
sir.
No.
No,
sir.
sir.
Why?
Say if we put
But sir,
0,
one
then
is
If you
odd.
take if we take 1, then if we add it to 1, it becomes root 2. So root 2 we cannot get 1.
if
Sir,
we
if
put
we
0,
take
It
zero,
doesn't matter. I
yes,
mean,
it
there
will.
can be some other natural number for which we are getting 1. So you have to prove that 1 is not an output. Suppose for some n, which is odd,
If you
I
put
am getting
minus
1
two.
as an output. Suppose this. Suppose I am getting, for some n, I am getting this as 1. Okay. If I square it, I will get this, I will get this. But when I can apply this one, when n is odd, but 0 is even. So this cannot give 1 as an output.
Yes.
The first one. What about the second one? Can this give 1 as an output? If
Sir,
this
but
give 1 as
0
an
is
output,
neither
then
even
this
nor
1.
odd, sir.
1 is not even.
Now this is odd. But it happens for what? It happens for even number.
Even.
So this also cannot give 1 as an output.
Yes.
So no, there is no such n for which I can get 1 as an output. So 1 is not inside the range, but it is inside the codomain. So range and codomain are not equal.
Yes.
So this is not on.
Not on.
Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes.
sir.
Yes, sir.
Okay. Great.
Sir,
Great.
0 is neither even nor odd. No, sir. 0.
Generally we take at even 0. Because 0 is, multiple of 2, so it's even. Okay.
Okay, sir.
So, yeah.
Sir, this real number could not go back to the natural number side.
So there are some real numbers which cannot be mapped by that particular map, root n plus 1 or root n. So there are no such natural number for which I can get 1 as an output. So there are some real number which cannot be got as an output of the function. So this is not all. Yeah.
So I guess that is the most difficult part. Like you thought that 1 should be the value which does not satisfy this condition. But if we did not thought, then we might say that it is on 2 as well.
You have to
So
check. You have to check for
we have
which.
to check
I
for
mean,
more than
this will
one.
come from practice, and whatever you practice, that will be more and more clear from your intuition, right? So first thing, there are many numbers, not only one. There are many. This is not only one example.
Sir, what about
There are
3 by
many
4?
numbers which cannot be got as an output of this.
Sir, for 3 by 4 we can get 1, no, sir.
Huh?
For 3 by 4 we can get 1, no, sir.
3 by 4, is 3 by 4 natural number, first of all?
Have to take natural
Because
number.
it should come from natural number,
Real
no?
number, no, sir.
No, domain should be
But
natural,
domain we
right?
have-
So input should be natural number. So you are taking 3 by 4 as an input. That is not inside natural number. So we cannot take it as an input, right?
Yes, sir.
Yes, sir.
Domain is natural number. So, and how 3 by 4 can go to there? First of all, 3 by 4 is not a natural number, so we don't know whether it is odd or even. So which one we should apply? And even if we apply root of 3 by 4, it will never give you 1. I don't know why, how we have come to this 3 by 4. I am not getting this. Okay. Anyway, 3 by 4 is not a natural number, so that is enough to say that the output
Hello,
of it
sir.
does not appear. Yeah.
Hello, sir.
Yeah.
Sir, I have a small doubt in step, sir. Sir, A backslash B. So the backslash means I'm minusing the elements of the B from A, right?
Just go back to the recording of this session. At the beginning, I have said that. So A minus B is basically all such elements which are inside A but not in B. Okay.
Okay, sir.
So this is A, this is B. Suppose this is A, this is B. This portion is your A minus B. This portion. Okay. This is your A minus B.
Just verifying it, sir.
Yeah.
Yes, sir.
Yes, sir. Yes.
Great. Okay. So clear till now what we have discussed? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, great. What about this one?
Sir,
B.
this
Option B.
this
B
class,
Option B.
the recorded
Oh.
class will, the recorded class is going to be put it in YouTube. How long it takes?
Yeah, it is live stream
The
already.
first option, sir.
Okay, I will see
The
that.
second option, sir. Second option.
So there are so this is what we have to find the domain of this function, right? What is the domain of this function? Right? So all such numbers for which the function is well defined. Now there are two things for this function. X plus 3, x minus 5. So whatever, if we have this type of function, this is kind of rational function, right? Some p by q form of function. When I am explaining something, can you please mute yourself? Okay. So there are
Sir, can you repeat?
rational function. Yeah, I am starting. So this is kind of rational type of function, right? Something in numerator, something in denominator. So what is in the denominator, that can never be 0. That is the first condition. If it is 0, then the function is not defined at that point, right? So when this is 0, when x equal to 5, so x
Then
cannot be
x
equal
is
to 5, right? So x cannot be equal to 5. That is the first condition. Now, what is the second condition? So something, if it is inside square root, if something is inside square root, we are talking about real numbers, right? So that can never be negative.
Yes.
So x plus 3 can never be negative. So it must be greater than equal to 0. So x should be greater than equal to minus 3. So there are two conditions which I am getting. All such x. So here, if you see the question, this is inside z. Inside z. That's why they have mentioned z. So even if it is real number, then also if you will write the x belongs to R. So that is there. So all such x for which x is greater than equal to minus 3 and x not equal to 5. These two conditions should be there. So this is basically your option B.
Okay, sir.
A is greater than
Yes.
equal to minus 3. 5 is already there, so I am eliminating 5. So option B is there. Okay. So this is what we have done. So this is then have to greater than equal to minus 3, and I am eliminating 5 from that because 5 is inside this set. So minus 5. So I am removing 5 from that. Okay.
Can you
That is
please
what
show
I
the
am.
backslide?
Yeah, this is backslice. This is minus. This set minus 5.
No. Can you
That
please show
means
the backslide, previous slide?
this one.
Yes. Okay.
Okay, so I have written x not equal to 5. So this is nothing but taking this set and removing 5 from that.
Continue as the same or the different one, sir?
Which one?
The continue as the same. The slide you are changing the what? The slide you are changing the different one or the same one you're going to continue?
No. This slide I have all the questions and solutions there, and this is what I am writing to explain something. Okay.
That's okay.
Next.
Excuse me, sir. Can you also explain the range for the same question?
Yes, sir, please.
You tell me what is the range of this question, range of this function.
Question is 6 to be changed as this.
Can we get any real number as a output? That is the first question. Can we get any real number as an output? So suppose I am giving you any real number, A. Can you give me some any real number A? Can you give me some number for which I am getting this? Can you find some x?
Excuse me, sir?
That is the question, right? When I am explaining, can you please hold your question? Our function is from z to r, right? Where it is integer. Remember, it is integer. So, for any, I want to find x, which is integer, for which I am getting a as an output. So, what I need x. This is plus 3 or minus 3. What was there? Plus 3. X plus 3 by x minus 5. This should be a. I mean, can we get such a? Which is so integer, right? This should be integer.
Yes.
If it is real number, first tell me for real number. Can we get some real number for which this is happen?
Sir, from 6 we can get.
Huh?
Sir, above 6. Equal to or above 6.
Why equal to or above 6? If it is real number, then what is happening? I can take square of this, right? I can do this a square, and then I can move x here.
X square. X plus 3. That's fine.
So I will get a 2-degree equation. Right? I need to find x.
Minus y is equal.
But we have to exchange.
Plus 25 square minus x minus 3 is 0. So I am getting some equation in x, right?
It comes to codomain.
Give me a minute.
Yeah.
25 square minus 3. I am getting something like this, right? And then I can solve x. So this is not already taught in your course, but it will be in week 3. That this is a 2-degree equation, and you know how to solve it, right? By Siddharajah formula.
Yes, sir.
Yes.
So you can calculate a discriminant and see whether x is a real number or not. So this is your b square minus 4ac. That is, if that is real, then x has a real solution. If x has a real solution, then definitely for any real number there is a real x for which I am getting this a as a integer. Then this is on. But in our case, if f is z, I mean domain is z, then it does not always guarantee that I will get. I mean, this x will always be an integer. That does not guarantee for any a, right? So there may be some a for which I am not getting any integer. So can you give me some example of a for which I am not getting any integer as an input?
Sir?
Yeah.
Sir, x is equal to 6, sir.
Sir, it is equal to
I get
6.
9, sir.
If you say a is equal to 6, are you saying that?
X equal to
Sir,
6.
x is equal to 6, sir.
X is equal to 6 and A is equal to 3.
No, that is not doing anything. What you have to see, you have to give me any real number which is not an output. So you have to give me a for which I will not find any x, any integer for which this happens. So can you give me any such a? That is the question.
Excuse me, sir.
Yeah.
I think the finding
Sir.
Sir, excuse me.
Yeah. Tell me.
Sir, is this method that if we want to find the range, then we put this x plus under root x plus 3 upon x minus 5 is equal to y. Then we convert the x in term of
instead
y.
of y, I am putting a. That is what I have done, right?
Then we calculate that. After that, then we can make.
This is what I have done.
Yes,
Instead
sir.
of y, I have put a, nothing else.
Without getting the equation, we cannot predict this.
In this particular problem, we cannot. This is quite, complex function.
Yes, sir.
So that's why I am getting
Sir,
this
I think all positive real numbers could be the domain.
No, not necessarily. Suppose
X equals 5 will not be
A is equal
the
to
domain.
2 and less than 2. Will not get any domain, sir.
okay, why? Suppose a is equal to 2. A is equal to 2. What will be my x in that case? Can we get some x for this?
The quadratic equation will be formed.
Again, we have to solve quadratic equation, right?
Yes, sir.
Plus 3, 4x minus 5 whole square. This is what we have to solve.
Yes, sir.
Right?
Discriminant is less than 0. So imaginary roots for the quadratic.
What? What? Tell me.
Repeat again.
Sir, you are taking 2 as a codomain, sir?
2 as an image I have taken. 2 from the codomain.
Yes, sir. Sir, so we can take first image only. Directly we can take the image, sir, or because
that
we
is what
should
I
have
have
take
taken.
first.
A is
Okay,
equal to 2. X plus 3.
A is equal to 2, and I am now trying to find some x. Now, whatever the solution of x coming from here, if this is an integer, then it will be an input. If it is not an integer, then we can say that A does not have any pre-image. Is it clear?
Okay.
Yes, sir.
Okay.
Sir?
Yeah.
We
So
cannot
this
make.
is again, I will not solve this. This is.
Sir, we cannot make
So
directly.
we can do.
Hello, sir.
Yeah.
Yes.
We cannot make directly comment without formula. First, we have to derive the formula. Then after we can comment.
Right. So suppose I am giving you this function. Z to R fx, just this one. I am simplifying this. Now is it onto?
Onto.
Is it on? Yes.
It can come.
No, yes.
No, sir.
So it's come.
So first of all, can you tell me what is the range of this function? So there are two things.
The range of domain or
greater than 0. Numbers.
It will not come.
So there are two things.
0 to infinity.
Sir.
Okay. Now let me tell you. Suppose I am doing this same function, but I am changing the domain. Here this is real number. Here this is
not on.
Okay.
Decimal is not present.
Now let me finish that. Okay. So suppose I take 2. 2 is a real number, right? Oh, whatever. 1.
Yes, sir.
1. Take 1. 1 is a real number, right? Can I get 1 as an output for this function?
No, sir. No, sir.
So
X is equal to minus 2.
Yes, sir. Minus
3.
If X is equal to minus 2.
So X is minus 2.
It
So I
will be
can
2,
get,
sir.
right? I can get something like this, right?
1.5, sir. You cannot get 1.5.
So I'll come to that. Now, what happened if it is... So if I take any integer, then I will get a solution, right? For this. Correct? Any positive integer. I can get a solution for this. Now, if I, instead of 1, if I take 1 by 2, what happens in that case? This is also a real number. Can I get a solution for this?
1 by 4 minus 3.
So this is x plus 3 is 1 by 4 and x is 1 by 4 minus 3. So this is not an integer, right?
Yes, sir.
So this is not inside the domain if my domain is z.
Yes, sir. You are right.
So if my domain is z, then 1 by 2 does not have a pre-image.
Pre-image. Yes, sir.
Correct?
Right.
So in this case,
sir, if you take...
Not on 2.
So if you take the x value as a 1, how we can get x is equal to minus 2, sir? Because it will be root of the 4 and
no,
the
I
x
am
will
not
be
taking
2 now,
x
sir.
equal to 1. I am taking my output to be 1. I am finding what is the pre-image of it. I am taking 1 from this side and I am finding some number for which I am getting 1, and that element is minus 1. Okay, that is what I have found.
Right.
Now I am taking 1 by 2, but for this I cannot find any integer.
Yes, sir.
For which the output is 1 by 2.
Right, sir.
Clear?
Yes, sir. Clear.
So this is not
So
on.
if we go by like this, if we take first domain, sir, we can find codomain, sir. But we go through finding codomain to domain, we can miss some element, na, sir.
Yes, you are right.
I mean, what is this question? I am not understanding.
If we take the first
So see,
yes,
what we
first
have
we
to
take
do.
the domain values, sir.
Yes.
No. See, what we have to do. We are checking for onto, right? So we have to take element from the codomain and try to find some element in the domain. That is what we have to do. That is what we are doing. Right?
Okay, sir.
We cannot start from taking element from the domain. That will not give us anything. Okay? Because onto definition means what? Onto definition means every element of the codomain must have a pre-image. So we have to start from the element of the codomain, and we have to find whether that element has a pre-image or not. Okay? That is what we are doing.
Understood.
So this is not onto. Is it clear?
Understood. Right, sir.
This is not onto.
Sir, I have a query. So do we need to take some random numbers and check whether it has a pre-image or not?
If you can find the domain codomain directly, then range directly, then you should not.
Sorry, sir, not clear on this. But how do we hit and try? Like, how can we perform that?
Let me explain this.
Okay, sir.
So you are not giving me finish everything and asking out in between. So if I take this function, can you tell me what is the domain of this function? Sorry, what is the codomain of this function? Codomain?
R.
Real number.
Okay. What is the range of this function?
Integers.
Numbers more than 0.
Greater.
Any number which is greater than
R minus
0 and above.
Which are not decimal.
Sir, 0 and above.
No, why? Any number which is greater than 0. This is R plus. This can be any real number, but it will be positive always, right? Root of something. That is a positive number, whatever that is. You put any real number here, that will always be a positive real number, correct?
Yes, sir. Yes, sir.
And that will be a range. Now, here, you know what is your range, right? And that is not equal to codomain. So you can directly say that this is not on. Here, we don't have to go to trial and error method.
Yes, sir. Right.
Okay? But in some cases, when we are not sure what is your range, like if I just change this domain, for the same function. Now I am not sure what is my range, because now I cannot say just R plus, because even 1 by 2 is inside R plus, but still it is not in the range. So there are many elements which is not in the range. So basically the range of it, if you calculate it, it will be only the positive integers Z plus. Again, it is subset of R. It is not equal to R. So it is not on. Is it clear?
So it means that range and codomain should perfectly be equal to be on
Then only we can say it is on. Yeah. Okay. So in most of the cases, you can find some random number which is not in your range.
Yes.
You can find this. This is not very difficult. So the earlier question, this type of question will be very complex. This type of question will generally not come for checking what is the range of it.
Yes, sir.
Okay, because this is very complex range you will get.
Yes, sir.
But this type of question can come, whatever I have written here.
Okay, sir.
Then if this is this question, then you know range is positive real number, you can directly say this is not onto. Here also you can say this is not onto directly, but if you have to give an example, then you have to find some random number which is, so basically this should not be an integer after solving x. So I start with a rational number, 1 by 2, which is not an integer. And I see that what is the solution for x in that case. That is not an integer, so it is not inside the domain.
Yes.
So it is not inside the range. 1 by 2 is not inside the range of the function. Is it clear?
Yes, sir.
That's so like there is a complicated question in one of the AQs regarding finding the domain. Like
finding the domain. Finding domain is easier.
Finding
domain finding we have done. I am talking about range finding.
Yeah, but even like for domain, it's a very long question. Somewhat
Tell
like
me that
14 minus. Yeah, I remember like not completely, but it goes like under square root 14 minus 3x plus 35 minus 15x upon 4. So it's such a long number. So then how to find the domain?
What? Tell me slowly. What next to that?
Under square root 14.
14 minus 3x.
Yeah. Then bracket open. Like the bracket
Under
was
the root
open.
itself.
Yeah. So everything is under the root. It's 14.
Okay. That is not difficult.
Okay. It's 14 minus a bracket open 3x plus 35 minus 5x upon 4.
This one, are you talking about this one? What I have written?
Sir,
this one?
Yeah, I'm not sure about the digits exactly,
Okay,
but
at least this type of question, right? This you are saying this is long question, right?
Yeah,
but I am saying this is not exactly a very long question.
This is easy.
How to find the
exactly. Because domain means what? Domain means for which this function is defined, right? And for defining this function, whatever is under root, that should be greater than equal to 0.
Greater than
right? Now we have to solve this inequality, and that is easy, right? If two number is greater than equal to 0, that means what? Either both of them is greater than 0 or both of them is less than 0. Now you will get 4 inequalities and see which x are basically inside the domain, which x are actually outside that inequality. That is what you have to do.
Okay. So anything that would be coming outside the square root has to be positive, right?
Right. Because inside square root we cannot have any negative number.
Yeah, because it will become complex then.
Right. So all such f for which whatever is under square root, if it is greater than 0, then only the function will be defined. And that is what your domain is.
Yes,
where the function is defined.
So, sir, finding the range is
always
very
easy.
complex.
Finding a range is difficult for this type of function.
Yes, sir.
Okay, sir. Got it.
Generally, finding range, we generally don't ask for this type of difficult function. But for simple function like fx equal to x square plus 3, can you tell me what is the range of this function?
Range.
This I can ask.
Positive.
Greater than equal to.
From 3
Not
to
only positive.
3 into
Greater than 3.
Greater than 3.
Yes, sir.
So x
Yes,
square is
sir.
always greater than 0. So x square plus 3 should be greater than equal to 3. So all such real number for which x is
Greater than
greater
equal to
than equal to 3. That is your range. Yeah, this you can ask. This you can find it. And then
Sir, for the previous question, sir, it is x is greater than 28, right, sir?
Which one?
Sir, the root question.
I don't know. She just told me something. I just written an arbitrary number. You check it. What is 0 rate? Okay, whatever that is, you can solve it. I mean, this is not very difficult. Okay. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, great.
It's over, sir.
Great. Yeah. So these are all the questions we had to discuss. I hope it is clear.
Thank you, sir.
Can you take more
Thank you,
questions?
sir.
Sir, thank you.
Yeah.
Thank you, sir.
Thank
Thank
you,
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
I shall.
Thank you, sir.
Sir, I have one more
Thank you
doubt.
so much, sir.
Thank you, sir.
Sir, I have a doubt.
Yeah, tell me. Tell me.
Sir, I have a doubt in equivalence relation, sir.
Okay.
Sir, the question
What
is. Sir,
So can you tell me when we call a relation equivalence relation?
Sir?
When we call a relation an equivalence relation?
Sir, if it obeys
Reflexivity.
reflexivity, transitivity, and symmetricity.
All these three are satisfied. Yeah,
Yes, sir.
correct. Okay. Now, what is your question?
Sir, A is set of all lines, sir.
Okay. Are you asking something from graded assignment?
No, sir.
Okay. Set of all lines. Okay.
Sir, R is relation. They are perpendicular, sir.
They are perpendicular. So, suppose can ALL be inside that relation? Same
Sir,
line?
No, sir.
Can same line perpendicular on itself?
No, sir.
No. So it is not reflexive, right?
Yes, sir.
Okay. If one line is perpendicular to the other, can we say the other line is also perpendicular to the previous one?
Yes, sir.
So is it symmetric?
Yes, sir.
Now can you do the reflexive on your own? Transitive on your own?
Sir, transitivity only I have a doubt, sir.
Then I have to give you the solution. Okay. So this one, L2. L1 is perpendicular to L2. Okay. Now L2 is perpendicular to L3. Over here, L3.
But they will be parallel, no, sir.
They will not be perpendicular. So it is not transitive.
Not transitive. Yes, sir.
Sir, if we consider it in 3 dimension, it is transitivity, no, sir.
No. We are talking about line in 2 dimension.
Okay, sir.
Okay, fine. Okay, good night, everyone.
Have a nice day, sir.
Thank you, sir. Good night, sir.
Thank you, 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 sir.
Thank you.
Thank you, sir.
Sir, hello, sir.
Thank you so much, sir.
Sir, hello.
Sir, gone.
Gone.
Yes. Is there any Sahil? Sahil, are you there? Sanskar?
Should I call anyone, sir?
Yes.
Yes, please, sir. Tell me, sir.
What?
Sir, do you need any help, sir?
Yes.
Yeah, tell me, sir.
Sir, is there any Sahil and Sanskar?
No, I'm not a sir. Sir is gone.
Oh, okay. I am finding the Sahil and Sanskar.
Oh, okay. I don't know who is she.
Not C, he.
Oh, we. I don't know. I am also student.
Okay, okay. What's
Thank
your
you.
name?
My name Kumaran Orke.
Kumar Morke. Okay. Are you from where?
In Tamil Nadu.
Tamil Nadu. Wow. Nice state. Nice state.
Thank you. Are you from?
I'm from Rajasthan.
Oh, very nice. Oh, thank you. Nice to meet you. Bye.
Nice
Good
to
night.
meet you. Bye.
Good night. Good night.
मोबाइल नाम तो हैंग होने लगा।